Hey everybody, tonight we're seeking negative solutions, negative real solutions to a not particularly common equation type. This is a fractional part, the fractional part squared, and I have the definition of the fractional part. Let's just do a concrete example. Let's just say we wanted to do the fractional part of, let's say, 8.3. Okay, now intuitively you know that is 0.3, but this definition is useful as far as solving this problem. The fractional part is the number, the real value, minus its floor. Okay, so this would be 8.3 is our value of x. Now the floor, that's the greatest integer that's less than 8.3, is 8. And so we get 0.3, which is exactly what you'd expect without a formal definition. So it's 0.3. Let me make a prominent decimal point there. All right. Now notice also that in general, 0 is going to be less than or equal to. Now we're working with positives here. It's a little strange with the with negative values, but consistent. But anyway, the fractional part is always going to be a number between 0 and 1. Now notice that the fractional part of an integer is just 0. For example, the fractional part of 8 would be 0 because there's no fractional part. There's nothing after the decimal. Okay? Now this example right here is just to show you it's a little weird when you work with negative numbers. You would think the fractional part would be some negative 0.3, but it's really not. The floor of minus 3.3 is negative 4 because that's the greatest integer that is less than minus 3.3, okay? So these minus signs offset right here, and you actually get a plus in between here. And so you get 0.7, which is sort of counterintuitive, thinking of that being the fractional part of this, huh? You know, but anyway, it keeps it consistent in the sense that it's the fractional part is always a number between 0 and 1, okay? And there's two definitions. I think this is Graham's definition right here. This guy right here is Graham's. There's another definition where the fractional part is negative, I believe, but it's a Sawtooth function if you want to draw a picture. But what happens here, this truth right here implies this. If you take a look at this, our original equation, since this object is always between 0 and 1, and when you square it, it's still between 0 and 1, you can see where this comes from, right? In other words, you have 45, 1 less than 46, traps x squared above and below, okay? Now, we are looking for negative solutions, and so this is equivalent to this statement right here. Notice when you multiply through by minus, you reverse the sense of the inequality. So we know that our x value, we know that negative x squared has to be trapped between minus 46 and minus 45, okay? Now that implies this square root statement. And we're not technically taking the square roots and ending up with imaginary numbers, but remember that the square root of 49 is 7, right? And so this looks backwards, but if you think about the real number line, minus root 46 is greater than negative 7. You know, if you just think about the left to right nature of the number line. And so our the floor of the x we're looking for has to equal to negative 7. These are the conditions imposed on the x variable, right? It's trapped, the squared portion of it is trapped between minus 46 and minus 45. That implies that the floor of such a x would have to be minus 7, okay? And so that means we're going to use x plus 7 in place of the fractional part of x. And that's what happens right here, folks. See how we just replaced this with x plus 7? That's the fractional part in the interval of interest, which is just fairly narrow interval right here, okay? And then if you expand all that out and do the quadratic equation on this, I didn't show you all the work, but if you expand this out, you get 2x squared plus 14x plus 3 is equal to 0. If you apply the quadratic equation to this, you get two negative solutions. Know that this number right here is barely negative because minus 7 is the square root of 49 would be 7, right? So you can see this is going to be a large negative number or a small negative, an absolute value, however you want to think of it, But notice also that the fractional part of this, or excuse me, the floor of this object, and if you'll allow me, just so I won't have to write it down, the floor of this object doesn't meet our requirements. And it's not hard to verify here, if you just think about the size of this number, that the floor would be equal to -1, which is, and I'll just put this for emphasis, it's not equal to -7, right? And we know that has to be the case. That has to be the case. The floor of the x we're interested in has to be equal to -7, okay? So we don't have to check this one, but if we check this one, we check this guy right here, and again, I didn't show a lot of the work, but we substituted this value, which does have a floor of -7, not hard to verify, and we kind of can see it from our work we did before, right? Okay, so when you substitute this in here, notice that this becomes a +7 right here. You see how it's a -7? Well, I'm actually adding 7, you see. Remember, the floor of x is equal to -7, so that means the fractional part is going to be x plus 7, right? And so that's what I do right here. I add 7 to this, but remember, let me just write this out. 7 equals to 14/2. And I was just running a room. I probably should have shown you one more line of work. 7 is equal to 14/2. So if you add 7 to this object, you see, okay, which is what the fractional part is. Again, you see fractional part squared, and the fractional part is x plus 7. Here's our proposed x. So if you add 7 to this, that's like adding 14/2 to this, but notice that changes this to a +7, you see. Changes this to a +7. It'd been better if I'd have just shown you the work, but it's kind of clumsy to show all that. But anyway, when you expand this out, you can sort of see a lot of stuff cancels, and it does check, okay? So this green solution, that's our answer. X equals to this value here. It is the only negative solution. And this is the check, albeit not, I didn't show you a lot of the work, but anyway, this is the solution, ladies and gentlemen, to this original equation. And I thought it was a fun problem. Hope you enjoyed viewing it.